Hi there, my name's Andy Young and I'm one of the automotive lecturers down at Unitec in Auckland, New Zealand. And welcome to my Andy Mechanic YouTube channel. Now at the moment at Unitec I'm currently teaching what we call our fuels course, and in that fuels course we cover all sorts of things about ignition systems and fuel injection systems. And on the fuel injection system, one of the most common checks is to check an injector. And these, over time can go outside specification and cause the engine to run a little bit on the lean or a bit on the rich side, or not very efficiently, basically. Now there's a few checks that you can do on these on car before you take them off, before you think there's a real problem with them. Now, unfortunately, these are the ones off that little Rav4 that we pulled apart, golly, about 6 months ago it was quite some time ago. So I can't do any on-car tests with these anymore because the whole thing's in bits. In fact, it's all over the workshop and I can't wait to get back together again. So what I've done is I've rigged up basically a rig to mimic what will be happening on the vehicle. But I've done it using a flasher relay because I've slowed the whole process down and I want to show you, how we can do a test using that logic probe that I built the other week. And this is one of the reasons why we get the students to make these, because A, they're really useful, and checking for injector operation is absolutely perfect for this kind of tool, basically. So I've rigged one up in the vise, and when I turn the power supply on, it's going to actuate the injector, which basically means giving it a 12-volt feed, because all injectors get a 12-volt supply, and then the injector will turn off again. Now, on a car, the period of time the injector's actuated, it's turned on, is called the duty cycle. Now, if it's only on for 10% of any given moment in time, in any given period of time, then we call it a 10% duty cycle. If it's on for 10% and off for 90% of the time. Obviously, if we want to give the engine more fuel, or the ECU decides the engine needs more fuel for whatever reason, then the duty cycle will increase, and the period of time the injector remains open for, its opening period, extends. So it might go to 20%, it might go to 30%, it might even go to 40%, depending on how big the truck is that you're overtaking and how steep the hill is you're trying to get up. So we're going to head over to the vise and I'm going to show you how, using this logic probe, you can basically check, or one of the ways you can check for good operation of that injector. Here we go. Okay, so I was going to do it in the vise, but I decided to do things a little bit differently. Now, what I've rigged up here is I've got a 12-volt power supply. Now, that's not obviously a battery, but it will be the battery on the car. I've had to use about a 55-watt bulb to trick my flasher relay, or provide sufficient load to the flasher relay, to talk technically, to get it to operate correctly and at a reasonable speed. Now, this is just an old-school 2-pin kind of mechanical type flasher relay, so it's very dependent on load. So I've just used that to mimic the actual turning on, energizing we call that, and de-energizing, turning off of the actual injector, which we've got here, look. So when I turn that on, you'll see that whenever the bulb lights up, the actual injector's operating. If you listen really carefully, yeah, okay, you can hear the relay, the flasher relay clicking as well, but believe me, this relay, I can feel it actually clicking inside. And we can use our logic probe to prove that. Now, all you need to do is connect your logic probe to the positive and negative of your battery. In this case, that's my power supply, so I'll do that now. And you should see, as per the logic probe video, that both the two LEDs are illuminated. Okay, you can see the green one there is lit, as is the red one. Now, as a proof of concept, if we touch battery positive, then the red light will get a bit brighter and the green light will go out. We can do that, battery positive, there you go, look, red light on, green light out. And battery negative, green light brighter, red light out. So we know that if we're going to get a positive signal, we get a red light, and if we get a ground or an earth, then we get a green light only. Now, on the injector itself, there's only one single winding in there, and we've got 2 pins, so each pin is one end of that winding inside. Now, injectors are negatively switched. The switch is part of the ground circuit, so they get a positive live. So you can get your logic probe, and you can just back probe using a pin, and there's a video that I've done on how to back probe. You can then use that pin onto the actual connector on the vehicle and connect then your logic probe, the little end of it here, look, the pointy bit, onto the actual pin to get a contact. But here I don't need to do that because I've got the plug off. So the red wire is permanent live. So if we touch on there, we will get, you can see that on the camera or not. There you go, look. Green light goes out, red light stays on. I know it's a long way from the camera, but I think you can just about see that. There you go. Okay, so the other side, the black jumper lead that we're using here, will be the actual switched ground. Now, therefore, when the switch in the ECU is in the open position, we should get a live, a 12-volt signal on that wire. But as soon as that switch in the ECU closes to turn on or energize the injector, we should then get a ground signal. So we should see it alternate, and that's what we're looking for. And if I just connect that on there, can you see? Oh, you can see that pretty well actually, can't you? There you go, look. You can see it switching from positive, 12 volts positive, to ground. Red being positive, ground being the green. Now, obviously on your car, the injector actuates much, much faster than this, and that's also dependent on engine RPM. But I thought it'd be quite a good experiment, a good demonstration for you to show this testing process slowed down and what you should be looking for. Now, obviously, when you're using your logic probe on a vehicle and testing an injector on car with the engine running, this whole process will be massively speeded up. And all you got to do is really see a flickering between red and green on your logic probe, but that will tell you that it's switching. So there you go. That's how we use a logic probe to test for an injector working correctly as regards the actual voltage side of things. Now, one more, that's getting quite warm actually, one more test that we can do, because there's no fuel going through it. That's why, because the fuel helps to cool the injector. There you go. So we'll turn that off for a minute, let things cool down, because that Rav4 really does need to work again one day. That's the plan. What we can also do, because there's a winding inside that injector, we can grab our multimeter, stick it on ohms, on resistance setting, and we can check the resistance of that winding and make sure it's not too high or not too low. And I'm going to talk to you about the problems that you can experience with an injector that has an incorrect resistance value. But first of all, let's check it and see what it is. Now, before you do any kind of resistance checks, it's really important that you check your meter for resistance. So pop it on the ohms setting here, look. And this has got an auto range, but I hate auto range because often I forget to take note of what the range is when I'm writing down the reading. So I've fixed it on ohms. It can't move around on this particular one. So we've got ohms there. And then all we need to do is connect the 2 leads together. You can see that, look. Connect 2 leads together. There we are. All right. And if you take the lowest reading that you get, that's the important thing. Wait for it to settle. And fortunately, this is quite a good meter. And we've got essentially 0 ohms. Now, obviously, there is a bit of a resistance, but it's insignificant for this particular check. And the lower the ohms specification of whatever you're testing, the more important it is to do this. And then if you do get a reading, deduct your internal meter test reading from your final reading of the component, and that way you're going to be a lot more accurate. And if it's a really low ohms reading that you're taking, a specification, this is dead important. Otherwise you might fail the component when actually it's fine. Okay, now I'm not going to use the same injector that we've just been using on the rig, because the coil is pretty hot, and as you know, heat affects the resistance of a wire. So I'll use a new one. This one's nice and cool. I say new, it's one of the other 3 that came out of the vehicle. So it's definitely not new. And we'll head down to the 10 tools mat, and bit of a plug, and we will take a resistance reading of this unit. Now, all you need to do, just to show you very clearly on here, you can see just in here the 2 pins. Okay, it doesn't matter at all which of your test leads you put on either pin. Just make sure though that you get a good connection. And those little test leads with the little crocodile clips on the end are much better for this, because you can clip them on and then you get a really good reading. So there you go, just those two pins, very important. Make sure they're nice and clean. If they're all corroded and gummy, then obviously there's a point of high resistance and that's going to cause a problem. So make sure they are nice and clean, and you can get some super special sprays nowadays that clean contact connectors for electrical stuff. So do that. Okay, let's head over to the mat. Right, so you've got your injector, and this can be done just as easily on car. It doesn't need to be done off car. And just position those on there like that. That's one. There's the other. Let your meter settle, because it has a little think. Okay, 13.8 ohms. Wow. Okay, well, according to specification from Toyota, 13.8 ohms, I'll put it on the screen for you. For this particular vehicle, for this particular injector unit, 13.8 ohms is exactly what we should be getting. Okay, well, let's check the other two while we're on, because we're already set up. What the hell, let's see what we get for those. Now you see that one's a bit different. Okay, 14.1 on that one. Let's just do a double check, make sure we're getting good connection. Ah, there you are, look. Okay, it does make a difference. Right, 13.8. Perfect. Right, one more. Let's see if we can get this one aligned. And then what we'll do is we'll test that last one that's on the... Should have cooled down a bit by now. Yep, super. 13.8. Right, one more. Let's see what we get with this one. It is still a bit warm, so it might affect the actual reading, but we'll see. We can always test it again later on. Yes, that's quite different, isn't it, I reckon? Oh, it's dropping. Should be a bit longer. 14.1. 14.1, yes, it's slightly higher, but it is warm, and it does tell you to check them when they're cool. So there you go. It does make a difference. But the actual specifications do say approximately 13.8 ohms, so there's a bit of leeway there. Okay, so we've checked injectors using our logic probe that we made, and you could do the same thing with a test light, I suppose, but the test light would just light up when it's not being energized, during the off period of the injector, and then the bulb would go out when the actual injector is on. But whether a festoon bulb would react fast enough with the engine running, I don't think it would actually. I don't think you'd see much of a flicker. I think it would just look like it was permanently on. Not very much of a good test, to be honest. But it does depend on your test light and how good they are. But an LED based test light, those LED bulbs, whatever they are, they can flash on and off much faster. So that's one of the real benefits of those. One more thing you can do if you want to, again on car, and I couldn't really demonstrate it off car, but you can actually hear these things click when they're actuated, when they're turned on. So if you get a screwdriver and you put the head of the screwdriver, make sure it's clean, put the head of the screwdriver against your ear and the tip of the screwdriver on the body of the actual injector, you will hear that clicking sound. You can obviously use a stethoscope if you've got one, but there's no need. If you've got a big long screwdriver, a nice long shaft on the screwdriver, then you're not getting your head too close to the engine. And of course you can also get away from that engine noise a little bit, and you'll be able to hear this click, 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 click in your ear. And that again tells you that the actual injector is actuating. It doesn't tell you if it's in spec or anything like that, but at least it's not seized. At least it's getting a current. You know it's getting energized and it's doing some kind of work, basically. Okay, well that is all I'm going to cover on testing the basic tests of an electronic fuel injector. And these are very common on vehicles of sort of the late 80s, 1990s and early 2000s. Obviously it doesn't include anything to do with common rail. These injectors fit basically in the intake manifold or directly into the head, and they spray the fuel before the valve, upstream of the valve. So I haven't covered anything to do with direct injection, not with these. This is your normal sort of injectors, the kind of stuff that I'm really quite aware of, I would say, knowledgeable. Okay, now we were going to cover, actually I've just remembered now, we were going to cover what the problems are if you get a resistance value that's too high or too low. Okay, well, let's cover the one that's too high first, because that's pretty simple. Too high a resistance in those windings inside the injector really has to indicate the fact that there's some kind of corrosion or a partial break in the winding. If you get open circuit, then of course, open circuit, there isn't a circuit anymore, the winding has broken, and obviously current isn't going to flow, and that's why your injector isn't going to work and you're going to throw it away. If you just get a high resistance, or a higher resistance than spec, just slightly higher, then you're going to have some kind of corrosion in there or a partial break in the winding. And you also might find that as the injector warms up, that break, that partial break, that point of high resistance becomes open circuit. So as during cold start you're on 4 cylinders, but as the engine warms it drops a cylinder, that injector ceases to operate and you've got a permanent misfire. Under those circumstances obviously you'd need to replace the injector too, but it's good to understand when you've got a slightly high resistance winding on an injector, what's the real problem? Well, let's go back to basics, because that winding is there to create a magnetic field. So when it's energized, it creates a magnetic field, and that field attracts a plunger. It pulls the plunger upwards only by a very, very small amount. From memory, I believe it's about 0.16 of a millimeter. So it's a fraction of a movement. It doesn't move very far. Because it doesn't move very far, it means it can operate very, very fast. Very short stroke, so to speak. Now, the strength of that magnetic field is really important, and if we've got high resistance, that's going to reduce current flow, and therefore it's going to reduce the strength of that magnetic field, and the injector is going to open, probably, if it still opens, it's going to open slower than it should. There's going to be a longer delay from when the field is energized, or created, to when that nozzle, the valve inside the injector actually opens and allows the fuel to spray through, which means your car's going to run lean, or that cylinder at least is going to run lean. Okay, well, that one's pretty simple. But what if the injector's got less resistance than it should have when it was made? So in this case, for Toyota Rav4, it was 13.8 ohms. Let's say if you take a reading and you've got 11 ohms. How could that be? What's going on? Well, the wire inside the injector that makes up that coil of wire, the winding, so we call it, has got a very, very thin sort of lacquer insulation on it, and it can rub through, it can deteriorate over time, and those coils, can start to touch. I'll do you a quick drawing and show you what I mean. Okay, well, very simple diagram here. Imagine we've got a coil of wire inside the injector, and it has a resistance we've got here of 13.8 ohms standard. Now that resistance is based on the diameter of the wire and the length of the wire. Okay, well, the diameter is not going to really change very much. If it does, if it reduces due to corrosion, then that's going to go up. But we're talking about the resistance coming down on this example. Well, if that insulation breaks down, and let's say it affects, some of the windings in the actual injector. So now the current flow is going around this first winding, it gets to the second winding, and it jumps down, bridges across, let's say to, I don't know, all the way down here maybe, and it misses out going around some of these windings. And then it carries on going around the windings and heads back out to ground. Now, each winding creates or adds to the force of the magnetic field. So we're going to see, because overall the current is flowing through less windings, we're going to see a reduction in the magnetic field produced. Now sure, there's going to be more current flow, and that might help to compensate a little bit, but in reality we're going to see potentially less buildup of magnetic field. As a result, the injector is going to be a little bit sluggish to react again, and the vehicle, or that cylinder, is going to run lean. So based on that summary, whether the resistance is too high or too low, within reason, the injector is going to start to inject less fuel per given duty cycle. So it's not going to be spraying as much fuel into that cylinder as what the ECU sort of intended to happen. Now, there is a fail-safe system on these cars where you have what's called fuel trims. And as components deteriorate, especially injectors deteriorate over time, those fuel trims can be changed. So the ECU sort of learns what's going on. It's got an O2 sensor or more than one O2 sensor in the exhaust system. So it gives an actuation, it gives a certain amount of fuel to the cylinder or cylinders, and then the O2 sensor gives some feedback information to the ECU. Hey mate, you know, you're still running lean, or oh, you're running rich, you need to adjust it slightly. And the ECU makes those calculations and then sprays in a slightly different amount of fuel by adjusting the duty cycle. So, you know, if this was spraying in slightly less fuel than it should be, then of course the O2 sensor is going to say, hey, there's an abundance of oxygen in this exhaust, that's why I'm called an O2 sensor, and the ECU then would enrichen the mixture. So it would very slightly increase the duty cycle to all the injectors, not this one, but to all of them. So the overall result is that the exhaust fumes going out the exhaust attain lambda, or whatever they need to. Yeah, lambda, because it's in closed loop. So it would attain lambda. The problem is that the O2 sensor, okay, let's say it's an inline 4-cylinder engine, not a V8 with 2, but it's an inline 4, it's got one O2 sensor. That sensor is sensing the average of all the cylinders. Now when the vehicle's brand new, not a problem, everything works about the same and it's all good. But over time, those cylinders change in compression, you get variations between the injectors and so on. You will actually start to get discrepancies in performance per cylinder, and the engines will run a bit more lumpy, and the power output won't be as good and they won't be quite as efficient. So the only way to really absolutely guarantee an ECU could calculate for each individual cylinder is to give each cylinder its own O2 sensor. That would be fantastic. And then the ECU can fine-tune the mixture, the amount of fuel it's supplying to each cylinder. Wouldn't that be great? Too expensive, that's why manufacturers don't do it, but it would be a real solution to this long-term problem. Okay, so we have now covered everything I wanted to cover on injectors. I hope you found it super helpful. If you've got any questions, comments, or thoughts on what I've just discussed, you think something's wrong, I don't know. I mean, if you've got different ideas, then please do let me know, because I'm a lecturer and I'm always learning, as are my students. We're always learning through going through life, and there may be different ideas about certainly the resistance side of an injector. This is as far as I've gone with my knowledge, and I'm only really applying logic to what I see happening inside that injector, and what would therefore happen on the vehicle. But yeah, who knows? Okay, crew. My name's Andy Young. I'm one of the automotive lecturers down at Unitec in Auckland, and you've been watching the Andy Mechanic YouTube channel. If you would like to subscribe, then click on the subscribe button, and then you'll see a little gear icon. Click on that if you want notifications, turn them on, and then whenever I upload a new video, you'll get an email sent through to say, hey, Andy's uploaded a new video. Do you want to watch it? I do that to all the channels that I watch, and it's really useful. Helps an awful lot rather than having to keep going back to those channels and seeing what's new. You'll also find me on Facebook, Instagram, Twitter, Google+. So feel free, if you want to use any of those portals to communicate with me, you can do, but I would urge you, please, to use YouTube as your primary, first port of call, because you may be asking a question that somebody else also has a similar question, and once I've answered it, they can scroll through the questions and answers and maybe find the information they need before having to contact me, because sometimes I can't reply straight away. I'm quite a busy chap doing a lot of teaching and other things. Okay, what else? That's about it really, isn't it? Okay, crew, thanks for watching. Over and out.